Good evening. Good evening. You're welcome to our today's class. Today we'll take a look at pharmaceutical calculations. And this is a review class. We've done this in the class. So on daily basis, we pick one topic and solve some questions on the topic so as to prepare you for the exam. In our last class, we looked at concentrations. So today we'll take a look at dilutions. So we'll pick some questions and see how far we can go before our time elapses for today. So we'll take a look at dilutions, and our dilutions that should be the 10th topic. That should be the 10th topic. Yes, dilutions. All right. Dilutions. Of course, without understanding concentration, you find it difficult to understand what? Dilution. So if you have a particular solution with a given concentration, and if you want to dilute it to produce another solution, the same content but different what? Sodium chloride in what? In 100 what? Mil. That's the meaning, right? But let's assume we have this and we want to dilute this more. What you need to do, you're not changing the amount. This is the amount. This is the what? The amount of the what? Solute, which is sodium chloride, and this is the amount of the entire what? Product, the volume. This is in what? Weight. Now, if you want to increase the concentration of this, so if you want to dilute this solution, that is decreasing the concentration. All you need to do is just to add the what? More of the what? Solvent. Simple. Here now, of course, you know that the solvent is water. This 0.9 gram dissolved in what? Water. So if you want to decrease the concentration or dilute it, all you need to do is just to add more of the what? Solvent, which is water. If you do that, you have diluted it. Or you say you have decreased the what? Concentration. If you can remember what we did on this topic. Now, this is 0.9 gram of sodium chloride in 100 ml solution. You may decide to make the entire solution 1000 ml by adding 900 ml of water. If you add 900 ml of water here, the entire volume will become what? 1000 ml. The amount of sodium chloride is not changed. Hope you know. What you just change that you increase the what? The solvent, which is water. But this is still the same 0.9 gram sodium chloride. Now, if you now want to find this concentration, the concentration of this 0.9 gram in 1000 ml, see what you have. Of course, if you have 0.9 gram in what? 100 ml. If you want to move it to percentage strength, you find it in 100 ml. How many will be in what? 100 ml. How many will be in what? 100 mil. So which means that X, this is now the X. So X is now what? 0.9 gram times what? 1000 mil. You are cross multiplying now. All over what? 100 mil. So if you divide, if you make cancel mil, 20 here will take care of 20 here. You are left with what? You are left with what? So you are right. I made a mistake. Sorry, you are right. You are right. It should be what? I call this one 1000. It should be what? 0.9 gram times what? You are right. Thank you for that. 100 mil. I like that. That means you are following. Divided by what? 1000 mil. Thank you for that. So mil will do what? Cancel mil. This 0 will do what? Cancel this 0. So 0.9 gram, 0.9 gram divided by what? 10 will not be what? This should be 0.0 what? 9 gram. It should be 0.09 gram. So we have 0.09 gram of sodium chloride in what? 100 in 1000 what? Ml. So if we have, sorry, we are moving to 100 ml, right? Sorry, in 100 what? Ml. Remember we said that if we have increased the volume to what? 1000 ml, but we do not touch the what? The amount of sodium chloride. If we have 0.9 gram of sodium chloride in what? 1000 ml. How many should we have in what? 100 ml. So if you multiply, we have 0.09 gram in what? 100 ml. So look at it now. Look at it now. It was 0.9 gram in 1000 ml. In 100 ml, it has gone down to 0.09 gram. What does this mean? This means what? 0.9 what? Percent weight in what? Volume. So the concentration now moved from 0.09% weight in volume to what? 0.09% what? Weight in volume. So you have decreased the what? Concentration. If you dilute, you are decreasing the what? Concentration. Can you see it now? You have decreased the concentration. Remember what we discussed about the concentration of the new solution you form by diluting this solution. And this is the second, the dilution formula where we say some volume. So this is, if you judge by what you did now, tell me which one did D1 V1 is equal to what? C2 V2. While C1 is the concentration of the stock solution, the solution you want to dilute. Do you think should be the C1? Good. 0. What? And V1 is the volume of that what? Solution. While C2 is what? Is equal. If we are judging by this now, which one do it should be? V1. It's 100 mil. 100 mil. C2 is what? 0. What? 0% weight in volume. V2 is what? 1 year. Let's check whether this is actually true. Let's do as if we don't know. Okay, let's go. That C2. So we make solution what? C2 is not what? V1 over what? V2. From this thing we listed. Remember we are doing as no. Okay, let's let me V2. Zero point what? 9% weight in volume. Sorry. Why am I making mistake up and down? What's going on? C2 is what? C. What? What? 0. What? 9% percent volume will cancel percent left with volume. So multiply this by 0.0. The answer. So that formula is actually what? Correct. So if you have a question like this, you can solve it directly like this, or you can use the what formula that you use will give you the answer. But just remember that it's not all the time that volume must not be 100 at any time. Let's 100. As you may see, the volume may be 200. That it must be that what may. So this is basically what dilution formula. A question that has to do with this. Now we get one or two solution to get new solutions. Please, before putting it down, while I look for question. I don't. Let's look at. And the question is, what weights of potassium permanganate required to produce 100 ml of solution, such 25 ml of this solution to 12 ml gives 0.1 weight solution. Right, let's solve this question. If you look at this question, certain potassium permanganate used, okay, was due to dissolved in what? water, a 300 ml solution. Tell us the weight of tomato used. And they didn't tell us about the weight, the volume of water they used. And the final solution was what? 300 ml. Good. Now, from that solution, 12 ml was taken from that solution produced. And that 25 ml was further diluted to produce 300 ml solution. And that is the concentration of what? 0.01% weight in water. Now, we will need our dilution formula in this question. So, dilution formula first. Using dilution formula, C1V1 is equal to what? C2V2. You know where the issue lies? Which one is V1 and which one is V1? That's where the issue lies. Now tell me, which one do you think is the C1 here? C1, not volume. Concentration. We don't know. It wasn't given. Which one do you think is the V1? First volume. It's not 30, it's not 300. This is just the volume of the stock solution produced by dissolving potassium in it. It's from 300 that the one that diluted is not the whole that was diluted. Remember, having it was the whole this will now dilute the first volume. But from diluted was just from this 300 ml. So they just 5 ml and that. So the first volume is this 25 ml or 300 ml. Are you clear? So here now is what? 25 ml. Sorry, we don't know. That's what? One is what? Good. So what? 0, 1, what? Then V2 is what? Even the still one is a common so that you can't be, but there's no way you can have 300 and then 300. This one is that will tell you that this is not the first volume. Let's continue. So now let's find this one. Is it clear? So from here now, C1 is equal to 2 over what? V1. So this implies V1 is now equal to what? T is what? 0.01% what? In volume. Times V2 is what? Over V 25 ml. Let's time. What's the answer? Even though this one should give you 12, it should give you 0.1. The answer should be 0.12, if I'm not mistaken. So here, 0.12 what? Count me. So what? And what? What in vote? Is it clear? 0.1. So what we do now is the number thing in 300 ml to solution. We just calculated. So the 300 ml solution is what? 2% in volume. And volume to find the weight of potassium is here now. We have to open the mean of 0% in volume. Using what 9% volume. Use that same idea to tell me what actually means 0% in volume. So 0.2% what in volume? It's simply 0.12 what? Remember, 0.9 percent to what? 0.9 gram in what? 100 what? Mil. So this one is what? So what it means is that if you say that a 300 ml has a concentration of what? 0.12% weight in volume. What it means is that 0.1 of that solution contains 0.1 of what? Potassium permanganate. That's what it means. The 100 ml solution contains 1 gram of permanganate. But what was 300 ml? So if 100 ml potassium permanganate solution contains 0.12 gram of potassium permanganate, 3 will contain what? We contain X. Is it clear? So X is equal to what? 0.12 gram times what? 300 ml over what? Mil will cancel mil. 100 will divide 300, we have 3. 3 times 0.12 gram is 0.36 gram. 0.36 gram. Is that clear? So what it means is that the 300 ml potassium permanganate solution will contain what? 0.6 gram of potassium permanganate. So actually, the amount of potassium permanganate that was used to prepare the solution was actually what? 0.6 gram. Clear? Please ask if you're confused. Is it clear? So the answer is actually what? 0.36 gram of potassium what? Permanganate. Our time is almost up. I want to give you something. Tomorrow is what? Wednesday, right? Tomorrow we'll look at it. Okay. We'll take it to try to solve it. Tomorrow we'll look at it and see what you're able to make out of it. Okay? This question has to do with allegation. If you take a question, go back to what we did in allegation. Try to look for that formula. Try and solve it on your own. Okay? So if you come tomorrow, I will see what you're able to do. Okay? I will not tell whether it is allegation or allegation. We don't tell you. I don't want to tell me. Go back notes, go back to your textbook, go back to your course material, look at the question, try your own answer. The question says, find the volumes gram per 5 mil and per 5 mil solutions respectively would be required to do 600 mil of the 5 mil solution. So today, go to your course material mixing question, then try and solve it. Solve it so that I'll see of it. Then we'll take it off from there. Okay, any question? I thank you very much. See you tomorrow. We've come in a few minutes time again for tennis class. Honors.